I have a problem. I have this giant graveyard of side projects that I never finish. And I keep making new ones, too. The same thing happens every time. I have an amazing idea, hack something together, and it seems pretty promising. I spend like half a day thinking of a clever name, and then buying that perfect domain. And this one's going to be the one. This is going to be my killer app. And then suddenly, the curse of the side project hits me. A day goes by, a week goes by, and I never touch the project again. The more I think about it, I think there are three main reasons that this happens to me. One is scope creep. I have a cool idea, and then I have 10 more cool ideas, and soon the project is so huge there's no chance I'll ever finish it. Another is changing priorities. Maybe it's just not a good idea. But the big one can be infrastructure and scaling. I don't want to under-engineer my app and have it go viral and suddenly have to rewrite it from scratch so that it doesn't crash. But I also don't want to spend a ton of time making that perfect architecture that nobody's ever going to use. And the more I think about it, this doesn't just happen for side projects. It happens at work too. So really, I think this is a problem with projects in general. But I'm talking today because I finally finished a project, and I want to show you. So I created this web app called React Roads. I think it's pretty cool and it's interactive, so I'd love for you to visit it right now, and we'll all look at it together. So a few months ago, I found out that the United States Census Bureau publishes a list of every single road name in the United States. So I did whatever any React nerd in this conference might do, and looked for roads that sounded like React terms. And then I made a React app to view it. So for example, we have CAD React Road Vermont. Turns out JavaScript wasn't that interesting. There are no roads named JavaScript in the United States. But Cache was pretty promising. It has a ton of results. Now, this project had the hallmarks of something that I wasn't going to finish. I got a kind of cool domain name, reactroads.web.app. I also had scope creep. You can see there's a vote button here. And if I vote, the votes update in real time. And as you're doing it, the votes are coming in too. Besides that, I also have a leaderboard at the bottom that shows the most popular road globally. Currently, Suspense Drive, Florida is really popular, 16 votes. Oh, Arctic Cache just took it over. Oh, it's back. All right, let's see which one wins later. But even though this app is pretty simple to use, it has some decently complicated stuff behind it. The streaming in live data is pretty complicated. If I was doing it myself, I'd have to stand up a socket server and deal with all those things. I also have to be pretty confident that it'll scale, since I'm showing this at a conference to everybody who's going to click it at once. So how did I do it? How did I finally finish this project? I let someone else do the hard work for me. Now, this is kind of the big reveal, but it's probably not a big surprise because of my electric yellow Firebase shirt. But I used Firebase. So my name's Jeff, and I'm lucky enough to work on Firebase. And one of my roles is to try out our new products to make sure that they make sense for developers like you and me. I've been doing a lot of React stuff, and I really think that Firebase is the best way to build your apps quickly in a way that will scale. So Firebase is a great platform for building your apps, but it actually started out as something else. It started out as a chat app. In 2011, a company named Involve was founded, and it was actually a widget that any developer could embed on their website to get real-time chat between users. It was fairly popular, but over time, something weird happened. People started hacking it, hiding the UI, and using the real-time chat functionality to send JSON between users to power a game. Now, the Firebase founders looked at this and said, hey, maybe our infrastructure is more interesting than our chat app. So in 2012, Firebase was founded. And at the start, it really was just the backend for that chat app. There was global data. Everyone in the world could read it. But it allowed users to communicate in real time via JSON. Since global user-readable data isn't that useful, the next thing that came out was Firebase Auth. And that allowed users to sign in, and then allowed developers to configure security rules on the real-time database to make sure that user data wasn't exposed for anyone to read or write. With those two things, real-time database and its security rules and auth, it was possible to make pretty complicated apps without any backend at all, just with the client talking directly to the Firebase servers. The last step was a way to serve static files, JavaScript, HTML, CSS. So then Firebase launched hosting. And with those products, you could build a pretty complicated web app with pretty decent infrastructure doing real-time things, all without managing your own servers. And it started to become a pretty viable platform. With that in mind, Google bought Firebase in 2014, and in 2016 relaunched it with a ton of new features. So real-time database, auth, and hosting are still there, but now we have a ton of new stuff. Machine learning features, cloud functions, and then also things for the lifecycle of your app, like performance monitoring, analytics, and A/B testing. Also, Firebase wasn't this insecure thing anymore. Some of the biggest apps out there trust it now. But this is all really abstract. Let's get back to my Roads app. For my Roads app, I use Cloud Firestore, which is Firebase's next-generation database. And like any database, you issue a query and it sends some data back. But it does a bit more than that. It can handle spotty internet connections really easily, since it maintains a local cache. It also pushes updates in real time back to the app, so that over time, as values change, like our vote counts earlier, the app updates seamlessly. It also scales without me thinking about anything. Firestore can support up to 1 million concurrent users, which is way more than my Roads app is ever going to get. I use Firebase hosting, which I mentioned before. That gives me a global content delivery network for my static files to make sure that my first page load is always quick. It also gave me that .web.app domain. Any Firebase project gets Firebase project name .web.app as a free domain, and SSL is set up by default. One thing you probably didn't notice when you're clicking around in my app was that I signed you in silently with one of my favorite features, Firebase Anonymous Authentication. What this lets me do is avoid a clunky sign-in flow, but still sign in users behind the scenes so that I know that when they're in the same browser, I can track which votes they've done and then stop you from voting for the same road twice. That's why the vote button changes from the word vote to a +1. Another thing you may or may not have noticed is that your vote button probably looked different from mine. I used Firebase Remote Config to randomly assign different values of prompt to the vote button. Half of you randomly got the word vote, and half got the plus sign. Now that's all good, but I want to know which vote button actually prompts people to vote more. And for that, I'll use Remote Config along with Google Analytics for Firebase. This gives me all the nerdy stats I need to know which button was most successful so that I can roll it out to all the users. All right, that was a lot of Firebase talk, but this is a React conference, so where's the React and where's the code? I've been working on a library called ReactFire that makes it really easy to integrate React apps with Firebase. It uses all the latest stuff, hooks, context providers, components, Suspense. And that means that it's still kind of experimental since Suspense for data fetching hasn't landed in stable React builds yet with concurrent mode. But I want to show it off anyway because I'm really excited about it. So I have about 20 minutes left. Let's see how much of React roads we can rebuild right now from scratch. So I've started with really basic boilerplate. This is probably familiar to you. I import React DOM, I have some styles, and then I render it. I have create React app watching my files, so I get this web page that says where are the roads in really tiny text. First, let's render that list of roads with some just dummy data, some mock data. I'll create a component called roadList for that. And I'll maintain the list of roads in state. Each road will have an ID, a name. I'll just make up Suspense Drive, Alaska. The United States state that it's in, Alaska. And the number of votes that it has. Then I'll just map over the list and render it. Now to save some time, I've created a presentational component that's really dumb and just uses some CSS to render a road in a pretty way. It's called road list item, so I'm going to import that now. And road list item takes as props the road object and what to do when we click the vote button, an onVote function. For now, I'll just mock it out to alert that we voted. All right. Looks like my auto importer has taken the day off, so I'm just going to import some stuff real quick. All right, and I have one more dumb presentational component that I'm going to use that just sets up the basic page layout. It's called page layout. And I'll render my new road list component in there. All right. And we failed to compile. Let's see if that fixes it. Cool. So now we've got the basic guts of the React Roads app. It's just a bunch of CSS at this point, basically. I mean, I have some mock data that's rendering correctly and a vote button that when I click it just alerts, like you saw. So let's start using Firebase. To connect to Firebase, I first need to tell the Firebase library what backend to talk to, what my project is. So I'll go to the Firebase Console, which is the place where I manage all things in my Firebase project. You can see all the different products I talked about before are listed down the left side. But what I'm interested in is my app's config. So I'll copy that out. And the console is also giving me some instructions on how to actually initialize Firebase. Usually in a web app, you treat Firebase as this global singleton, and you can call it from anywhere in your app. But I found that for React, that doesn't really work too well with the way I think about my components. Since everything's split up into those small components, and things are often lazy-loaded async, trusting a global singleton felt a little weird. So instead, in ReactFire, we use React's context API to expose the Firebase library. I'm going to paste this config before I forget. And now I'm going to use my first ReactFire component. It's called Firebase App Provider. As a prop, it takes the Firebase config that I just copied. And I'm going to wrap my entire app in it. All right, so if you're familiar with context, you'll know that with a context provider wrapping my app, every single child of it will be able to access whatever it exposes via context using React's useContext hook. So basically what I've done here is I've set up Firebase, and now any of my components can access the Firebase library to do whatever they want. So we're all set up to read some actual data. I've already loaded the roads list into Cloud Firestore. So first, I'll just access the Firestore library. To do that, I'll use another ReactFire hook called use Firestore. All right. See if I can get it to auto-import instead. Great. Like any database, I have to construct a query. So let's make a query. I'm using this term collection because Firestore is a NoSQL database, and its data structure is documents that contain collections of other documents that contain documents that contain collections that contain documents. And I know that I've stored my roads in a collection. All right. And now, the way I'd usually load async data and deal with real-time updates in React would be to use something like a useEffect hook and then subscribe to my query. So maybe I'd do something like query.subscribe, and then as new data comes in, I'll call this setRoads to update my component. This is basically how you would subscribe to Firestore, but since it's such a common pattern, with ReactFire, we've abstracted it away into a single hook. So that means I can take away this use effect, and I can actually take away this use state because ReactFire's hook also handles the state updates in the re-renders. So instead, I'll just write const roads, and I'll use a ReactFire hook called use Firestore collection data. And I'll pass it the query. All right. And that's about all I need to subscribe to real-time updates from Firestore. But something might look kind of weird to you. I'm not doing any kind of async handling. There's no state here tracking whether we're loaded or not. And that's actually on purpose. If we go to my live app, we can see that it crashed. And it crashed in a really helpful way. React says, error, road list suspended while rendering, but no fallback UI was specified. Add a suspense fallback component. So, like I mentioned a little earlier, ReactFire is ready for concurrent mode. And that means that in this use Firestore collection data hook, we actually tell React, wait, we're not ready, don't render this component until we hear back from Firestore and get our data. To tell React what to render while it's waiting to render us, we need to supply a suspense fallback. To do that, I'll use suspense, and I'll provide a simple fallback that's just some text that says loading. And I, again, just need to do a quick import. All right. So with just a few lines of code and some help from Suspense to do all of our loading state management, we now have some live data coming in from Firestore. And this is kind of cool, but stuff isn't really going to update in real time because we have no way to write to Firestore right now. When I click the vote button, it just still does that dummy thanks for voting thing. But voting is actually a little tricky. Like tracking financial transactions, tracking a vote count is subject to race conditions. And so with a database, you need some kind of transactional handler to make sure that you don't have a race condition that messes up your vote count. Since incrementing things like this is a pretty common pattern, Firestore has a magic value that you can set a field to let Firestore handle all of that stuff under the hood. It's called increment. I'll create it now. Now that we have this magic increment value, we can actually update a road document when we click the vote button. I'll access that same Firestore collection roads. But now I'll also access the specific road that we want to vote for and update its votes value with that magic increment. Cool. So pretty simple. And if I didn't mess up, we should be able to actually vote now. All right. And you can see we know that it's working because these values underneath each road are actually updating in real time too. So not only are we writing to Firestore, but now we're getting real-time updates back. And we're getting all of that with just a couple lines of code. But there is a problem here. I can just sit here and vote all day. In the original React Roads app, I could only click the vote button once before I was blocked from voting again. Since we don't want to trust the client to enforce these kinds of things, we'll use security rules instead and make sure that a user can't vote twice for the same road. But first, before we set up our security rules, we're going to use anonymous authentication to sign somebody in so that after somebody votes, we can track that they actually did vote for something. Later, we can use security rules to check that record of voting and make sure somebody doesn't vote twice. So we need some auth. In the same way that I imported the Firestore library with use Firestore, I can say auth equals use auth. Also, in the same way I can subscribe to updates from Firestore, I can subscribe to updates from the current auth state, whether or not somebody's logged in, by calling useUser. And I'll just do the imports. All right. So I basically want to silently sign somebody in whenever the roadless component is rendered to the page. To do that, I'll use a useEffect hook. In this hook, I'll just call auth.signInAnonymously, and that's all I need to get anonymous auth. All right, and looks like we're missing a useEffect import here too. Cool. Now that we've signed a user in, and we have a way to track the auth state, since it happens asynchronously, when the component first mounts, the user probably won't be signed in. We can now write to a new collection that we'll call users to track each user's votes. I'll update onVote. And the first thing I'll do is say, if we don't have any user, don't do anything. All right. And now I want to say, when we've successfully voted for something, I want to create a new Firestore collection called users. I want to access one user's document, which I'll key off the user's user ID, something I get from Firebase Auth. And I'll maintain a collection of which roads the user has voted for by creating another collection, a sub-collection, called votes, that has a document with the road ID. And I'll set just kind of a dummy value. All right. So just to recap, what I've done is, after we've successfully incremented the vote on a road, we then go into a new users collection, find the user ID, and then in that user's document, update a votes collection to make sure that we've recorded that the user has voted for a certain road. All right. Oh. Little typo. Great. And everything's still working too. Now, we don't have any security rules yet, so the behavior is going to be the same as it was before. I can vote as much as I want. But the cool thing is that we're now getting user data saved. If the conference Wi-Fi is kind to me, I can show you. Yeah. So now, besides the roads collection that I can view in the Firebase console that has all of our roads, there's this new users collection. It has a document keyed off a user ID, that sub-collection votes that I talked about, and the road ID that I just voted for. If I vote again for a different road, you can see that it shows up here. Now that I have this tracking, I can set up my security rules. So right now, my security rules for Firestore are set up to read true, write true. This means that anyone in the entire world can read my entire database and write to it, which is obviously a really bad idea, especially when I'm on screen at a conference. So let's fix that. Since rules is a different language than JavaScript, I won't subject you to me sitting here writing it. I'm just going to copy-paste some rules that I've already written, and I'll explain them to you. All right. So I've got these security rules. Every single time an app tries to read to or write to or read from Firestore, these rules are checked. In my users collection, I want to make sure that one user can't see which roads another user has voted for, just to protect their privacy. So I only allow reads and writes if somebody is signed in and if their user ID is in the path that they're trying to write to. Since I'm keying that votes thing off of a user ID, this will protect each user's data. In my roads collection, I allow anybody in the world to read my roads. This is important because that data is stuff that I want to show to everyone. However, for update, I do some more stuff. I only allow a client to update a road if the user is signed in, and if I check that user's document and the votes that they've made, and they haven't voted for this road that they're trying to update yet. So that's what protects me from voting twice. Another thing I did was I made sure that the votes value, resource.data.votes, for a road can only ever be incremented by 1. That way, somebody can't be signed in, have not voted for a road before, and somehow find a way to increment a road by 70 or something. And now that my security rules are deployed, if I come back here and try and vote again, I should get rejected. And there we go. You might have seen the votes number flash up for a second from 61 to 62 and then back down again. That's Firestore optimistically updating its local cache, but then checking security rules and saying, oop, no, we failed the write, roll back. So I can still come down here and vote for roads I've never voted before, like Suspense Drive, Florida, or Cass Street, Alaska. But I can't vote for them twice. Now, obviously, in Roads React, I had some nicer UI that actually hid the vote button also. But that's just more of like a nicety and user experience feature than it is actually enforcing the vote. Firestore security rules are what really powered that. All right. Well, we can do some other cool stuff with Firestore that you can do with other databases. You can order. So for example, if we order by name. And you can do limits. So we'll limit to 25 maybe. And if we reload, we can see everything's in alphabetical order now, and limit to 25. So in not that much time, I think about 18 minutes, we've re-implemented most of the functionality of that React Roads project that I showed you. We've fetched the data, we're updating in real time, we can vote securely, only once per road per user, and we can deploy it. I'm using Create React App, so I'll just build my static files. And then once it's ready, I'll run Firebase deploy to deploy to Firebase hosting. This might take a little while to do conference Wi-Fi, but we'll see if we can make it. All right, so I was working in the Firebase project called ReactFire-Berlin. So that means that I get the free domain reactfire-berlin.web.app. If we all visit that, we can see that the thing that I just deployed is there. And there we go. Woo! All right, we made it with a minute to spare. So we used a crazy amount of infrastructure that can scale up super huge, but we did it in only 20 minutes. I hope this inspires you to finish your own projects with Firebase quickly and scalably. You can do everything I just showed you with Firebase for free without a billing account, and only pay later when you need to scale. If you want to talk to me, I'm happy to chat about React or Firebase or any combination thereof. I'll be in my bright yellow t-shirt right outside. I'm also Huleatt on Twitter if you want to message me on the internet. And again, the library that I maintain that makes all this stuff possible is called ReactFire. So thanks so much. I had a blast building this. I'm so glad that the curse of the live demo didn't hit me and that we got it done. So thanks so much, and please do come chat.